Hey students, part 2 of this lesson coming at you. Let's make Elliot small. We're in part 3 now. Equation to graph of a quadratic. So if you had to graph y equals x plus 2 quantity squared plus 2. How you doing? I need you to be quiet because I'm filming on the internet right now. Uh-huh. Alright, so we're going to graph this equation right here, and it helps to know your parent function. And I'm gonna do this problem as if I'm on team graph paper first. Hey, remember team graph paper and team non-graph paper? Yeah. That was fun. So our 5 points, we have 0, 0, 1, 1, 2, 4, negative 1, 1, and negative 2, 4. These are the 5 points that create our parent function y equals x squared. Okay, so you take this equation right now, the plus 2, that is outside of the function, so it's going up or down, and we do exactly as the graph tells us to. We're going to go up 2. Inside the function, that tells us whether we're going to go left or right. I like to think what number allows this to be 0, and in this case it's negative 7. So it would be left 7. Not negative left 7, just left 7. I'll say positive left 7. Then what we need to do is we need to take our 5 key points and move them all 7 to the left and up 2. And Elliot has made a classic mistake in that where I built my original graph, I don't have enough graph paper to go left 7 and up 2. So it's kind of embarrassing. I'm just going to have to start all over again. I guess I'm going to make it over here this time so that I have enough space to go left 7 and up 2. Take my 5 key points. Alright, so then these 5 key points, if I move all 5 key points and move them left 7 up 2, 1, 2, 3, 4, 5, oops, start over. 1, 2, 3, 4, 5, 6, 7, up 2. That would put me right here. I do that with all 5 of these points, but once you have your vertex point as your reference, it's not completely necessary for the rest of the points, because I noticed that from this point to this point, from the vertex to these 2 points, is simply over 1 and up 1. And then from this point to this point's over 1 and up 3. And this one's over 1 and up 3. So that would be my 5 points right there. And then you can connect the dots. And you have yourself a nice looking graph paper parabola. That's graph paper technique if you are on team graph paper. If you wanted to do this problem and not team graph paper, you first would still want to identify that you're going up 2 and left 7. And if you're going to be going, let's start with the left 7. If you're going to be going left 7, that means to all of the x coordinates, if you're going to be moving 7 to the left, you're going to be subtracting 7 from that value. So it would be x minus 7. If you're going to be traveling up to a distance from the y coordinate, it would be y plus 2. And then you already know what the parabola is going to look like. The parabola is going to look like this, and I can go ahead and draw my 5 points of importance on it, and I just need to write what those coordinates are. The vertex point, 0, 0. 0 minus 7 is negative 7. 0 plus 2 is 2. So that means that my vertex would have the coordinate negative 7, 2. This coordinate negative 1, 1. If I go negative 1 minus 7, I end up at negative 8. If I go 1 plus 2, I end up at 3. So I have the coordinate negative 8, 3. You do that with all these coordinates, and you'd get all your answers. Now, in terms of showing your work, I tend to actually, when I do these problems, I tend to not show this. I tend to kind of work those problems in my head. I know with 1, 1, 1 minus 7 is negative 6. 1 plus 2 is 3. This point is normally 2, 4. 2 minus 7 is negative 5. 4 plus 2 is 6. This point's usually negative 2, negative 4. Negative 7 minus 2 is negative 9, and 4 plus 2 is 6. So the only work that you have to show is this work and this graph, but doing this work with all of the key points makes the math a lot easier for a lot of people, because then they can see it. 1 minus 7 is negative 6. 1 plus 2 is 3. So, and 2, 4 would become negative 5, 6. So if you are a work minimalist and you're in Team Non-Graph paper, make sure you're showing this and that. If you think showing your work is valuable, and it is valuable, students, you should be showing your work. You could show this part too. The last part, what if you are given a quadratic graph and you had to work to equation? I have a graph for you here. Usually when they give you graphs, they're not going to give you coordinates. They're going to give you an actual piece of graph paper with the graph on it. And let's see, I had that piece of paper I was showing during part 1 about kind of this checklist that you could work through. Let's see if Elliot can find it quickly. Alright, we'll give it 10 more seconds. Sorry, it's been 2 hours since I did part 1 of this lesson, and for some reason that piece of paper has gone away. Oh well. Well, if you recall that piece of that. Wait, no, come on, where is it? My lesson will be so much more awesome if I can find this piece of paper. Sorry, students, I cannot find this piece of paper, and I'm not sure where I put it. I'm going to have to print up a new one and bring it to my lesson tomorrow. Well, I do have an earlier copy of that. Oh, no, wait. It's right here, everybody. Let me show it to you. As I showed you in the last lesson, whenever you're given a graph you want to write an equation, try to identify the reflections first, but this graph doesn't have any reflections. You next one, identify dilations. There's no dilations. Then you start working towards the translations. Figure out if this graph is going up, down, left, or right. And if I look at this graph, I look at the vertex, because I know that the vertex usually starts at 0, 0. But in this case, the vertex is at 3, negative 4. So that gives me this guideline that that this graph is going right 3 and down 4. Well, if it's going right 3 and down 4, that means that the right 3, left or right, if you're going left or right, you subtract or add inside to the function by h. So it was going h, or 3, to the right. So it's because it was going to the right, I would subtract. So x minus 3 quantity squared. And that's inside of the function. And then for the down 4, because I was going down v units, that means I'm going to subtract outside of the function by v. So subtract the 4. So another way of looking at it, inside, when I think right, I think adding or pluses, so you do the opposite. Outside the function, you do exactly what you're supposed to, so you subtract. And that's writing an equation. Okay, everybody, so those were the 4 parts of today's lesson. We took some translations, and I gave you an equation and we graphed it. I then took a translation and I showed you a graph and you figured out what the equation was. And then we basically did the exact same thing in part, but we did it to quadratics. So in part 3, we did equation to graph of a quadratic, and then in part 4, using the quadratic, I gave you a graph and you wrote the equation. So essentially, those are the 4 different skills at this point that you should have in your back pocket. And the work that I put in these problems today is the same type of work that you should be using in your homework or in your practice, and then ultimately on the quizzes and the tests. So I hope you have yourself a great Wednesday evening, everybody, and I will see you on Thursday. Bye-bye.